So let's start. Let's resume. So you will practice. I hope you run the virtual machine or over on your Linux environment. You arrive until to this step. There is people that use AWS Web Service, Amazon Web Service in order to practice its works. So you can use it also. In the step one, the source code you retrieve, there is blanks in the code. So your task, your mission, is to fill in them in order to make the application working. The first step is to make the admin user. The admin user wants to add resources. So the step is to add the code in order for the admin to add resources. There is two blanks in the file provided here at the line. The line also provided at the end of the line. So go in these files. Read the to-do, the instruction provided, and try to implement the solution. If you have any issue or question, don't hesitate to ask for help. We are free that can help you. I will let you some time in order to make this task, and then I will show you the solution on the screen. So let's get started. Right. So the first file is in app fabric update, is the update file. So if you go in the bottom, the update add function is not implemented. So the goal here is to add instruction in order to allow the user to communicate with the blockchain, the Hyperledger Fabric network, and to ask to run in the chain code the right function. So look at slide. There is solution in slides before, and also there is just above this function there is another function that makes the same task. So this is for the application side, and the other parts that you need to implement is in the chain code. This is in the updates.go file. So the first step is talking about add a new resource. So the arguments is add, and you call the add function. In the add function, there is allow instruction. There is instruction that help you, also instruction that help you to manage in order to solve this problem. When you think you implement the solution, the only things to do is to run make. It will automatically clean your setup and deploy a new network with the chain code you write directly on each piece. and the application will use your solution directly, so you can test it using the make command. If you have any question, don't hesitate to ask. Someone need help before I give the solution? If you don't want to see the solution, don't listen. You want some time more?
Yes.
Okay.
If you want, there is just here. You can take a chair.
In the virtual machine, for people that want to use Vim or Nano or every kind of terminal editors you can, but in the virtual machine there is also the Atom IDE there that will help you with auto-completion in Golang syntax, Golang language. So I encourage you to use this soft. So, I will give you the solution for the first file to begin. So, if you run the make command before solving anything, you will get an issue so I run the make command before, and now I will go on the provided address. It will run, yeah. I enter the admin credential, admin1 and password. So I'm logging. So the goal is to add a resource. So now when an admin user wants to add a resource, so resource 1, for example, blah, 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 add the resource. So we got an issue that is not implemented. So this is the web server that responds with this error. And to solve it, you need to go in the first file we saw before, in the application side, so app, then fabric, then we go in the update file. So the goal here is to ask to the shellcode, to the peers, to handle the request and run the shellcode, is to ask to add a new resource. So to tell to the shellcode that we want to add a new resource, we use the same code, just like the update registers. But this time, we don't want to register a user, we want to add a resource. So this kind of string are already provided in the chain code part. So I don't invent anything. If you want to make something else here, you need to change it also in the chain code. So this is the add update function we want to call. So I give the first argument for that, and then I will give some information about the resource, so the resource ID and the resource description. To do so, we use parameters provided in the function, and we cast them in bytes. So resource ID and resource description. I hope I made no mistake. Okay, so this is the first step. Oh, I know that we need to use the add. To know this add parameters, we need to go in the chain code part. So in the other file, I go in the chain code and I open the update file. The first function handles every invoke request for the update part. So we saw the registers, and now we will handle the add. So the add string I put in the first argument come from there. If I want to make another string, for example, add resource, I need to change it also in the clients in the application side. So resource. Okay? So I use here the first argument. Then I call the add function that is not implemented. So I go into the add function just after the register. And there I need to use arguments provided. So arguments here that contains the resource ID and the resource description. I will create the data structures and I will use the util function provided in chaincode/util.go to put in the ledger the new structures. So, okay, every question before I give you the solution. The very easy implementation of this is to not handle we make any check on the user that makes the request. It's the first step. Then we check if the user is an admin user before adding anything in the ledger. So I go back to the slide. If I give the solution. So, if you want to get the solution on your machine, you just need to check out the step 1 solved branch that contains every solution of this step. So, let's see in details what we need to do. So, the update add, I just give you the solution before. So that's it. And for the chain code part, this is the solution. First, we check credentials. We check that the user that made the request is an admin user. To do so, we use the CID library that asserts some attributes contained in the certificate of the user. So I use this function to retrieve the attribute in the certificate that tells if it's an admin or not, and I check also if the value is the admin value that match the admin value. The actor attributes and model actor admin are in the model Go file. I show it to you. So in the chain code folder, then in the model folder, there is a model file that contains every data structures. So the actors that is implemented by the admin user and the consumer user is data structures, and then the resource. We also get the resource history for get details. You will see more information for that after. And also all constants used. So the object type, admin, consumer, resource, and also other constant for you will see after. So I use these constants there in order to retrieve the actor attribute in the certificate and also check if the value match consumer or admin. So this is the solution for checking if the user is an admin user before doing anything, because only admin user can make this kind of request. So the second step is to check arguments. We check that there is all arguments in provided, so the resource ID and the description. We check that arguments are not empty before doing anything. So that's it. And then we create the data structures for created a new resource that contain the ID, the resource ID provided in the arguments, and the description also provided in arguments that we fetched before. And we set that the resource is available. So the resource created is available at the creation. Then I call the util function update in ledger in order to put this structure in the ledger. So to do so, I provide to the mid function the object type. This is a resource. It's a constant in the model file. Also, I provide the resource ID and the resource, the data structures that contain every information about the resource. So you can go to the util.go file in order to get details about this function, but we call the stub put state in order to proceed this task. And finally, it's an optional part. We respond to the application by giving the resource, the data structure, the resource we created, but in the application we don't use it, so it's very optional. So we change the resource data structures in bytes using the object2byte function provided in util.go, and then we respond with a success, giving this byte response. So this is the solution, and then when all is implemented, so try with your code, or you can also, I will do it in the virtual machine in order to be all equals. So I stop the current server with Ctrl+C. I implement the solution. So to do it, I just check out the step 1 solve that contain every solution, and I just run the make command. It will clean up the environment, shut down the blockchain. That's why it's very useful to keep very simple these architectures. So it clean up everything, and it run it again using our new files. So we create the channel, the chain code, it install and instantiate the chain code, register users, and launch the web servers. If you have difficulties with the Golang language, there is not a lot of people that write in Golang. I can help you on this part to help you understand what the code means. So this is the registration part, the admin one. Also, this credential, admin1 and password, are not magic. They are provided in the app main file. So you go in the main and you open the main file. So there is all logic. So we retrieve flags from the CLI commands. We initialize the Fabric SDK. And we then install the channel and the chain code. And then we register user. So credentials are stored there. You can see that we register user admin1 and with the password, and consumer1, consumer2. finally, we run the web server. So credentials are there. Okay, you can change it if you want. So, I hope it's, yes, it's ready. So I open the web browsers. I log in. And then I want to create a resource. I hope everything is okay. So resource 1, blah, 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 add the resource. So the web server will handle the web request and make a transaction in the blockchain. So all happen behind the scene, and then the web server responds with OK response and tell that the resource is created. So everything seems to be OK. And if I go to the resource list, the resource was added. So, have you any question? No. Like I said before, we use CouchDB and not LevelDB in this network. So this allows us to see very easily the structure stored in the blockchain, the ledger states, the final ledger states. To do so, there is a graphical interface on localhost dot. I think it's, oh, I will retrieve. This is the Foxton interface. So this is on localhost. The port is 5984 the port and underscore utils. You will go on this graphical interface. The credentials are provided also in the fixtures folders for the configuration of the network. So I show you where are these configurations are. In fixtures, there is the AMP folders. So I go into the AMP folders, the fixtures AMP, and there is the configuration for CouchDB. I open the CouchDB configuration, and you can see there is credential in order to log in this graphical interface. So admin password, admin password. So when you log in, there is some database. There is one database for each chain code. So in our case, we use the database for the chain code ChainHero Resource Manager on my channel. And then when you go inside, you can see the current state of the ledger on the peers 0 or peers 1. So I connect myself to the CouchDB used by the peers, by one peers, in order to get information about the current state of the ledger. So if the last state, if you proceed every blocks, you get this state. So you can see some information. So this is the admin information, the user admin1 registered. We can see the name. Also, there is consumer 1, consumer 2, and also the resource we created using a new transaction. So each information are stored with a key. The key is here, and the value is that. So we can see in the resource structures that the resource is available, the description, blah, 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 and the ID also. So CouchDB with this graphical interface help a lot in order to know in which state are the current database and to make some debug. But for production, don't make this interface available, because this allows anyone to change the data structures stored on the peers. If there is an issue with the database, the only things to do is to remove the database and to ask to the peers to recreate it using blocks he contains. So he will proceed every transaction of every block and rebuild the final state of the ledger. So I will give you instruction for the step 2 to go deeper in the architectures, and if you understand more information with this solution, you will practice a little bit more. And for people that want more help, I'm here. So what about the step 2? So you need to check out the step 2 branch. So you need to discard, to remove every change you made and check out the step 2 branch. And there is also some blanks in the code, in the chain code update file and in the app fabric update file also. So I'm here if you have any question. So to continue with the step 2, go into your roots project, check out every file you change, and check out the step 2 branch. Okay, so like I said, in the chain code part, in the step 2, we want that the consumer acquire a resource available. So take a resource. So the first thing is in the chain code of the application. So in the application, in the fabric update file, if you look inside, there is also a to-do that tell you need to implement the update acquire a resource. So use what we saw before, and in the chain code folders, in update also, if you look for the update function, there is a to-do that tells you we need to implement this this acquire function. So people, if you want the URL in order to get detail about the network, this is the URL.
CouchDB or the algorithm are not complete. What kind of network do you use for the transactions?
I only start the net. That was my suspicion. So it's only the net.
I use these settings and it's for
Do you need more times? I give you a solution. Someone need help? Okay. So to retrieve the solution, like for the step 1, you can use the step 2 solved branch that gives you all instruction. So let's go deeper in the code. Step 2 solved. Okay, and start with the application side. So the update acquire resource. So we will call the chain code for an update. So we use the update function and we provide arguments. The first argument is to tell that we want to acquire a resource. So we put acquire, and then we give the resource ID, which resource the user want to retrieve to acquire. Then we give the mission, the description for which the resource will be acquired. So it's just that all the logic will come from the chain code. So go inside the chain code. Also in the update file. So in the update file, the first step is to handle the first arguments that it's for acquire a resource. So we check that, and then we create a new function that allows us to acquire the resource for the user. So to proceed this function, the first step is to check who made the transaction. Only consumers can make this kind of request. So we check, the first step is to check that the user is a consumer. So we assert attributes in the certificate of the user. We check that the actor attribute is the consumer. Then we check arguments, the length of arguments, then the resource ID, which is the resource ID, then the mission. And finally, we use the util function get from ledger that allows us to retrieve the resource data structure in the ledger using the objective resource and the resource ID provided in arguments. We provide the reference to the structures to fill in, and we add more logic. So, like I said, only resource available can be acquired by a consumer. So we need to check this point. We need to check that the resource is available. It is not the case, we return an error. Also, we need to update the resource to store the consumer ID that take the resource. So I retrieve the ID of the consumers and I put the ID in the resource data structures in consumer attributes. I also fill in the mission provided in arguments, and I set the resource not available anymore. I update the ledger. So I provide the resource type, the resource ID, and the structures I changed. Finally, I can respond with new resource structures by I transform the structure in bytes and response with a success with this byte response. A point on this update in ledger. Some talk before speak about that. In a transaction, when you use update, so put, so behind the update in ledger, there is a put state. There is we use the stub interface and we use the function put state. Every put state made in the transaction are not applied directly. So if in the same transaction you put state and then you get state just after, the response of the get state will not be the one you provide in the update state just before. So you can't update and then read from the ledger the same key at the same time in the same transaction. So you need to manage it, your code, in order to avoid this issue. For this example, just after the update in ledger, we don't make a get from ledger. We use the resource we put in the update function to make the response. We don't make a get from ledger to make the response. Because if we use a get from ledger just after the update in ledger, we will retrieve an old resource, the resource not changed. Okay, so you can test this solution with make at the root of the project. Like you see, checking a full chain code can take some time. So make unit tests in the chain code can improve your code before testing. So I encourage you to use the mock interface in order to test your chain code. And also, I encourage you to make some scripts that automate this test to not wait before the deployment and then test it on the interface, because it's not really direct. So now, when I log in into the interface, I first log in as an admin user. I create the resource. I add the description. And then I check that the resource is created and available. I log out. And I log in with the consumer one user, for example. So I go to the resource list. I see the resource available and I acquire the resource. I give a mission, description, and I take the resource. Like you see, the resource is not available anymore. If I come back to the admin user, we can see that the resource is not available and on the mission 1 that the consumer provide. We can get detail when, so just now. And we also get the transaction ID. It's like a proof. I'm a consumer. I can tell to the admin user, look at for this transaction ID. I took the resource, so it's a proof. And the last step is to look out in the last consumer, the consumer 2. There is no resource available and visible. Okay. Any question? Yeah?
Previously created a resource for.
Can you take a mic?
You previously had a resource created, right, before you did a make again, and it disappeared. So can you share some info about it?
So the question was why every data provided before in the ledger are disappear. Why we need to create a new resource again. Because when we run the make command, it clean up everything. So it shut down the network and remove every data provided. In a real production case, is not envisageable. We can't remove every data. You need to update the chain code. The update function are not provided in this project, but you can use the SDK Go in order to tell, I want to update the chain code. I want to update information stored in the ledger, so I update the chain code. To make things easier in a development environment, in some cases, it's easier to remove everything and start again. But to keep the resource, if you already create the resource and you want to update, you need to implement the update function that will be made by the application, that will package the new chain code, add a new version, and will install it on every peers. It's not really it's not a lot of work and allow you to avoid this task of remove all and start it again with a new code. Just update is enough. Okay. Other question?
What is the CouchDB name?
What?
CouchDB name, access the CouchDB.
Oh yeah, the link. This is the link to go to the.
Utils.
Yeah. So this port is configured in the Docker Compose file. The Docker Compose, if you look inside, so there is all containers, the orderer, the CA, the MSP, and the first CouchDB database for the peers 0, then the peer 0, and after the CouchDB for the peer 1 and the peer 1 containers. So to get this link, here to get this link is the default port in CouchDB that you enable and we allow to connect to it using this configuration. So we connect using the interface. We connect to the CouchDB of the peers 0. If we want to connect to the CouchDB on the peers 1, we need to use this port. Any other question? So the last step is to implement the release part. So you can check out the step 3 branch on your repository. I give less information now, so you can try to implement the last step in order to allow a consumer to acquire and then release a resource. There is missing blanks in the code, in the chain code, and also in the application, in the fabric folders, and also in the controller. It's the first time you go in these folders. If you try to solve a solution, look at over, search for other controllers that will give you all solution and all instruction in order to solve this problem.
how to present open the release. You can tell when I want to read communicate with 10 fields and compare results. They use the majority, for example, or tell me if there is not all values are false. Okay, these are only things to do, and to present also you need to answer. This is like this questions you say, right? Because there is one field that you follow, you change that. So in order to answer that, you need to change it. So how to recreate the database status and the ChainHero? You need to remove the database, and you tell there is a increment in the list. You can go inside the peer containers and use peer servers in the pit, in the command line, and you can there recreate the database. Really? Yeah. It's something it's implemented in this project, so it's native fabric. It's native fabric. Oh, that's it. Right. It's the only things to do with the curated data. Excellent. Thank you. It's a good idea.
So I give you the solution very quickly, and if you have any question, we can talk just after. You also can retrieve the repository when you go home and practice by yourself. So every file solved are in the step 3 solved branch. So in this step, you also need to add some code in the controllers, in the release resource controllers. So I check out the step 3 solved. Clean, it's not required. So, the first things are to add in the application the way to communicate with the shellcode. So we add in the update file in app fabric the update release. We add the function update release that gives instruction to the shellcode to call the release function and which resource by giving the resource ID in the second argument. Then in the controller part, so you need to go in the web folder, controllers, and see the released controllers. Release resource controllers. This function is not totally implemented, so I can explain a little bit. So when the page submits the request to release the resource, we go inside these controllers. We retrieve if there is query parameters to pre-select the resource. So this was already implemented. So the missing part was when we submit the resource. So we look at if the user asks to submit. If it is the case, we retrieve the resource ID provided in the form in the web interface. And then we call the function update release that we create before. If there is an issue, an error, we display the error, and finally we send the response. So it's a web code, so it's not related to Hyperledger Fabric. So don't spend a lot of time on it. And the last things in chain code. So in the update function, we need to create at the top. We need to create the entry point. We look at for the we check the first arguments, and if it's for release, we call the release function. We create the function. We create the function just after the others. Here. So for the release part, there is no check on the identity of the user, because admin user can ask to release the resource. It's its resource. The user possesses this resource, so he have right to release the resource, and consumer also have right to release his resource is acquired. So we check arguments, the resource ID, and we retrieve the resource in the ledger. We store it in the resource model structure. We check that the resource is not available. If the resource is available, it can be released. There is an issue, so we check this here. Then we check if the user is a consumer. We need to answer that the consumer that asked to release the resource is the one that previously acquired the resource. So if the user is in admin, we do anything. But if the user is in a consumer, we check his ID, and we check that the consumer ID match the consumer in the resource not available. This is not the case. It tells that another consumer wants to release a resource posted by another consumer, okay? And we don't allow that. Finally, if all is okay, we remove the consumer ID in the resource structure, we remove the mission, and we set the resource available again. We update the data structures in the ledger, And optionally, we change the resource in bytes and send a success response to the application. So that's it. You can test it if you want. The master branch have more features like delete resource. You can look it for if you want to see how to manage deleted resource. When a resource is deleted, the key value pair is removed from the ledger. So it's interesting to know how to get details of a deleted resource. So that's it. Thank you for your attention. I hope you enjoy this workshop. Don't hesitate to send me an email if you have an issue when you will practice by yourself. Thank you. If you have any question, we can discuss right now or after. That's it.